if arg2 less than 1, if we're subtracting 1 from it, is somehow suddenly then greater than 1, that would fall down this code. But that's probably not going to happen because we know maybe presumably arg2 is 1. So let's just kind of follow through with that train of thought here, thinking let's not take that if statement. If we were to do 1 minus 1 greater than 1, not going to happen. Let's hit the else statement down below. But if we do that, we set rbx to 1, which if we're checking if it's not equal to 0, which we know is now 1. So strange decompilation setup there, but that will actually tell us, okay, we call this conditional enter this rax2 will equal our DL main CRT dispatch, arg1, arg2, arg3 all being included. So we do follow through with this logic. DLL main CRT dispatch. Let's click into that and go see what that does. Oh, well, actually, taking a look at the code here, you could see a little bit more information on it either attaching, detaching, doing whatever it might do based off of arg1 or arg2 here. But that looks like regular handling for DLL. In this case, our arg2 were to be 1. If we were, again, working with that hypothesis, we do end up calling this thing sub 1800C6F whatever. We can double click into that, and then what do? Scrolling through to understand a little bit more regular startup lock, fast fail shenanigans, DLL main before initialized. That's going to end up initializing, having stuff run. This sub is just initialize slist head, nothing peculiar. Default, local, standard input and output options. Oh, and then we do something with a lot of data values here. And we could double click into these, data 1800C8 whatever, more zeros as we expand and explore them. I'm hitting escape to go back, by the way. Same thing with another, nothing all that interesting, but we do check after initialize, we use this init term function with data again, currently being zeros, and then data again, currently being zeros. But in between those two, we do see a subroutine, a sub that is really something interesting. What is that init term actually kind of doing? Because that seems to be the only thing that will happen in this conditional. Everything else is released. RDI check will go through with regular dispatch calls. Nothing fancy there. So that looks like the only thing that would happen if this is going to end up being returned out of the function here for our DLL CRT main dispatch, right? That function, if we go back into it, will do something with init term or init term. What is that? If we go Google init term. Init term underscore E from Microsoft documentations. Thanks, Microsoft Ignite. Internal method that walk a table of function pointers and initialize them. The first pointer is the starting location in the table. Ooh, and the second pointer is the ending location. So it's just defining bounds when we saw that init term thing, whatever. And if it's going to initialize and probably run some functions, like realistically, that means that what we just saw at the start, C8200 being the zeros above, and then just following that was the C8210 being the end. That means that in between here, this data that is a subroutine, double click on it, that's a function. Oh, wait a second. It says this function is too large to analyze. What was that? Yeah. Force analysis of this function. This may take a while. Okay, so giant bloated function, presumably. We can double click on that and we can see down on the bottom left, analysis phase 1, it is now analyzing to rip apart and see that function. Might take a little bit, so I'll pause and wait until we get there. Okay, so now that this big sub 18001000 is done analyzing, we can scroll through it and it's kind of weird. Like, you see all this? There's a lot of character variables being defined, a lot of 3333s randomly, like weird random stuff, just a bunch of variables being created, a lot of 3s, a lot of 33s in hex, there just seem to be odd. And this goes on and on for a long time here. If I scroll down, this must be why that function was so big and was not analyzed automatically. But if I were to, like, I know I'm looking at the pseudo C. Let me switch this to the disassembly and, oh, hey, Binary Ninja just took a second. It's hanging there because this is probably taking so much time. A little bit of lag. I'll see when this comes back to life. Okay, yeah. Coming back to us. But look, just everything you'd expect. Move instructions over and over and over again, adding to RSP and one new byte at a time. So presumably building out like another payload, like a second stage, and you see this hex 33 over and over and over again. Let's kind of table this for the moment. Let me bring us back to what would be the start of this function, where we could see all the move instructions start and then continue forever. But this is code, right? It will execute this and put this all on the stack. Ultimately, it's going to be loading something into memory. So let me rename this. Let me just hit N to rename this to like MW. We could add that status. Yeah. Like whatever, maybe right payload is probably a fine name. But once that's renamed, let's sort of walk backwards and kind of, hey, remind ourselves how we got to where we are. I'll hit escape to bring us back. And I do want to bring this back to sudo C so we can see some of the code. Because remember, we saw that inside of that init term sort of function between those two bounds. And that was in this subroutine that was all inside of, we could call this whatever we wanted to, but it was in the DLL main CRT dispatch. And that DLL main CRT dispatch was in the else statement of DLL main dispatch that we started with. But once we were done with that, we could see we're testing if RAX2, the return value of that, if it did not fail, right? If it's not equal to 0, then we go to this label. So I double click on that. Oh, it just brings us back up to the else statement that we started with to begin with, but whatever. Ultimately, that calls this subroutine, which calls this subroutine if R2 is equal to 1. So let's drill down to that. Oh, and what's going on here? We can check while current process ID is not equal to hex 1234. That's not likely. That's probably not going to happen because that's going to be a random process ID. That will be a true condition, so we'll enter this while loop. We can check if we can flush file buffers, and that will be the break. So assuming that's not going to happen, we keep adding to RBX in the loop, and maybe some way, somehow we'll follow through. Once RBX is greater than or equal to whatever hex value, we do something with data here, data underscore 1800, and this is memory that we could click into and take a look at. So it starts at 0, you can see that, and that's, I'm going to assume an iterator, right? Because we have a do while loop here, but they do something interesting. They have an I null pointer where they're sort of doing like an inverse index into a buffer, presumably, because they keep growing and adding this over and over and over again. But that's a different data value because the other one was ending in CA750. This ends in CA758. So double clicking on that, it starts as zeros, presumably, but this loop will XOR. Oh, XOR, you can see the clear as day, right? This line here, the caret symbol will XOR with hex 33, which is just what we saw when we got to see that other big subroutine function, and a lot of those 333 hex 33. So I'm curious, is that all the move instructions that we saw is just a second stage payload XOR'd with hex 33? We could probably take a look at that. We could extract that dynamically, but just to like go check at the very, very top here, the symbols, we did rename that to whatever payload. If I double click in here and go see this one more time in the disassembly, take a look at these move instructions, right? We start with hex 7E and then 69. So let me open up like Firefox. This can be super simple, super dumb and easy. Like let me just get genuinely CyberChef open. And then literally 7E69, that is hex, right? So we need to do from hex. And then we can say XOR with the key being hex as the option set 33. The output is MZ, the very start of a portable executable header or an executable.exe or .dll, right? So that whole subroutine, everything that we're seeing here is probably just another second stage payload XOR'd with hex 33. Let's extract that all out dynamically with a debugger. If I get back to the section that we were in when we saw this XOR operation, we could just add a breakpoint after that do while loop. Honestly, we could just hit F2 and you can use a debugger here within Binary Ninja. But I'll admit, I don't know. I've seen that do, I don't know how to set that up smartly with a DLL or dynamic link library. I do know that X64 debug, another debugger that so many people love, can handle that really nice and easily. It'll just use like its own internal DLL main to get smart and do that. So let me do that with X64 debug. Before we do run that dynamically though, we know and need to understand that, okay, running the process will put memory locations in different spots that will be different than what we would see in Binary Ninja, right? All because of ASLR, the address space layout randomization. So what we can do is actually open up the 010 editor, and I gotta give huge props, big shout out and big thanks to Nord Garen because he's taught me this. If we were to try and open up the fastmath.dll, that will actually tell us, look, you could use this template because they do have some smart understanding of what all these different file formats are to make the 010 editor a super smart and good hex editor. We can install that super easily. And now it'll know, okay, these are all these sections and headers and things that are important for the file that you're actually looking at. So I can drill down into, just down below here, the NT header, I believe, and the optional headers here. Going to the very, very bottom of this, we should be able to see what would be the DLL characteristics. Taking a look in that, we can go find, if I expand this out, the dynamic base. And that is what will allow us to, if I toggle this 1 to a 0, change this so we don't have the ASLR in action for this binary. I can hit 0 and then save, Control S. Now, when I open up our X64 debugger, and now we could simply open the fastmath.dll that does have ASLR turned off, so everything should match the same addresses as we've seen inside of Binary Ninja. And if we wanted to, we could go take a look at the options and preferences because we should see the default, like, hey, breakpoint settings will allow us to create a breakpoint, or we don't even have to, honestly, at the very start of this thing running. So honestly, we could smartly, safely hit go and go ahead and continue execution. And you'll see that it'll automatically bring us to the start or address of our entry point as we begin execution here. But we need to put a breakpoint, just as we know, right after this big long loop that would XOR that buffer and everything that we want to pull out to get that second stage payload, right? So that is at this address 1800C42E1. We can right click, copy that. And because ASLR is off, I could just hit Control G, and that will allow us to jump to or go to a location. And since we're running, we should be able to go find this correct expression as I hit Control V to paste that in. So I'll click OK, and that'll bring us to the same instructions. If I zoom in just a smidge, you could probably see this exactly the same disassembly that we would see inside of Binary Ninja. If I toggle that back to disassembly, yep, there's our call, NOP, and XOR work that we're seeing. So we'll create that breakpoint there, F2, to make sure that that is red. Now, as I do this, I do want to go ahead and hit go once again. Okay, cool. Now our RIP, or our instruction pointer, brings us there. And now everything is in memory the way that we would have wanted after it has decrypted or un-XORed. Hey, took out that hex 33 out of the way. So we could go determine from the data location that we know between the CA758 and the CA750. 750 should be the one that will now point to the start of our buffer. So let me go grab this address. I'll copy and paste. And in the dump, down on the bottom left of the screen, we should be able to go now see all this stuff if I hit Control G again to go to, pasting in that location. X64 tells us that is a correct expression. It'll put us in the right place. So I'll click OK, and this gives us these memory addresses. Now, if I were to actually go follow them, walk through this, I can right click at the very start. Let me go to follow keyword in dump, and we can put that in dump number 2 since we're already in dump 1 for the tabs here. If I go to this, Take a look. You can see the entire MZ header. This program cannot be ran in DOS mode, so we have the portable executable, the whole next stage binary DLL in memory, and we can just extract this out. Now here's the coolest thing. Here's what we can do. We could actually right-click this, really anything as part of this, and try to grab this in actually the memory map. So for the whole memory that we're currently seeing, and whatever page part we're actually in right now, we click that, you'll see that it actually puts us into this heap ID 0. That's the one that's highlighted in the about the middle of the screen. Now, if I were to right-click this, we can dump memory to a file and then just give us all the junk that's pertinent to the program execution right now, including the MZ header and the raw binary for our stage 2 payload, and just slap that on the desktop. We can call that whatever stage2.bin or whatever data.bin. We will need to carve out the executable. But because we know MZ, right, because we know how we can anchor and go find that in a hex editor like 010, we've already got basically everything that we need. Let's go open up 010 and let's try to open that. Let me open our data.bin, and now we could simply Control F and like just search for. If I toggle the format here, not in hex, but I actually just want simple ASCII, we know the very start is that MZ, the beginning of our portable executable. Let me hit enter, and there it is. We see exactly, just as we saw previously, this program cannot be run in DOS mode, and now we could carve out this file by simply taking the very byte before it, going all the way to the top, and climbing the mountain here, and then just hitting delete. And then we saved it, right? So we could save this now if we wanted to, or actually apply one of the templates that we know, like an executable template, to tell it, look, you're an executable file. Now, you are a .exe or a .dll. You're a portable executable file. So if we run this, now it smartly adds the colors and headers and everything that we've seen previously, but we could, if we really wanted to, go find the very end. And we don't have to, like this isn't super duper important, but it might be nice if we wanted to, hey, drill down to the very end here. You might be able to see occasionally in the minimap on the right-hand side. I don't know if my face is in the way, so let me move this just a smidge. You can see as I'm scrolling down, there are a couple blocks here like that are blue highlighted or any other important bits. So if I get to maybe the borders that you can see just on the very left and right edges, as I go find these little regions, I'm curious, where is the end? Do we get to one down below? Oh no, we don't. Okay, so this is the threshold that this bottom half does not have a border surrounding it to know that is an important and necessary exe portion. So this 0df0a whatever, don't care, let's select it all and let's delete it. That is still just leftover memory that we would have saved when we were looking at the binary and we saved it out of x64 debug. But data.bin now is only our stage 2 whatever DLL, right? It's an executable file. We know it's a portable executable file. So let's save a copy, call this stage 2.dll is probably fine. We could work with that. And now let's start the process all over again and open that up within Binary Ninja. Getting this, usual malware Russian Matryoshka doll one layer after the next. Okay, now back in Binary Ninja, we can go ahead and open up that new stage2.dll that we have prepped on our desktop. Now, once I open this, it's going to look pretty similar to what we've seen thus far. If I actually toggle this to sudo C, we should be able to see, just as we have previously, kind of a pretty similar structure to the very start of this code, the same way that the first fastmath.dll did. We know that it's going to do our DLL main dispatch. We know we have our security cookie function here, and we can rename that, walk through these usual steps. But once we get to our DLL main dispatch, you'll know we'll follow through with the if and else statement, where the else statement is what we would realistically take, but jump to the label that brings us back to the if condition, and then this subroutine that actually gets called. So we could click into this, but we start now to do something a little bit different. You can see in this code where we actually start to work with, the process environment block. And some of you might be pretty familiar, that is the PEB. And the PEB is actually some data structure that's inherent to all binaries or portable executables, actual programs that run on Windows, that actually has some really interesting data that could be used and abused by malware, because it can actually keep track of all of the imports or memory object stuff that it might use within the code and context execution of the program. In fact, it actually keeps track of the modules that it might use, like kernel32. Kernel32.dll is one that I mentioned specifically because it will have a method or an exposed function to load library or to load other DLLs, pull in other libraries that code could continue to use. So rather than our malware and the sample being something that could be easily signatured by antivirus, where it has the actual imports for maybe nefarious functions like, connect to a socket or encrypt something or things that could raise an eyebrow, well, it'll actually do some tricks with the process environment block and walk through enough of the data structure that it could reflectively, using its own components, hide and mask a sort of more subtle import or load library for something else that's not then hard-coded or seen in the contents of the binary. It reflectively imports the stuff that it needs with some other tricks. And that is ultimately the PEB walk or PEB crawl. We'll see that in action though. We'll dig into it a little bit more, but hopefully that's at least a crash course in that. Anyway, we know that this data value is going to end up being a process environment block, so we could just rename that to data_PEB or whatever, that's fine. We do see down below, if R2 is equal to 1, a conditional that should just be, again, the DLL startup reason. If that's the case, we will create thread with another subroutine. So create thread will run immediately some new code, and we can call this, whatever, MW malware start function or whatever for our stage 2. Double clicking into this, now we've got a lot more to work with. In fact, this is a much longer function that we'll explore soon, but you might have noticed just at the very, very top, kind of important here, look, they do start to work with the PEB. This RAX1 variable is going to work with data PEB with some hex 18 offset. So I think it's important to note now, we could actually retype this because the PEB, as it's working with it, is going to be a pointer to that type for the process execution block. PEB, that is the, process environment block, forgive me. So let me press Y on the keyboard, and the hotkey in Binary Ninja to retype is Y. We could just change that to a PEB, PEB, with an asterisk right there to denote that is a pointer. Now I'll hit accept, enter on that, and thankfully, this is pretty awesome. Binary Ninja will now just rework and sort of, analyze and give us a lot more of the C-like syntax for the structure components and things that are much more readable as we're kind of examining and reverse engineering this. So take a look. Now we could see how we would pull out parts of the PEB. In fact, the in-memory order module list. And that is, as I was talking about earlier, the data structures that could help the malware author track down the pieces and breadcrumbs that it could use to then reflectively load other modules or other DLLs and get access to code in another new sneaky way. But if I keep scrolling down, we could actually see some of this in that F link, and maybe some of you that have been cruising through Maldiv Academy or other resources are very familiar with this process. We could rename this to MW module list if we really wanted to, but down below, this one is the one that's the most important because it ends up doing some subtraction with hex 10, right? That is going to end up kind of realigning whatever offset as we're working through. We actually want to end up considering that as one of the entries in the loader table data structure entry thing. I'm not familiar with the name off the top of my head, but I believe what we should end up doing is taking that var 3f8 in this case and retyping that to, with a Y on our keyboard, it is just LDR, LDT. No, that should be LDR data table entry and asterisk, again, for it to be a pointer there. I actually don't see it auto-completing those, so I want to be able to add some of those type definitions and structures to Binary Ninja, and I think I can get those online from the x6040 debug headers that it might offer. Like Google x6040 debug PEB loader data table entry. Here's one result, x60 debug, source debug, ntdll, ntdll.h. I think this should, if I search for _peb, we do have the peb loader data, and I would like that piece. How about just loader data table entry? Do we have that? Yep, we do. We could grab that just as well. We can actually truncate some parts of this because we don't need all of it. Let me actually get a Sublime Text window open, and I will pull together some cooking show magic. This was from Nordgaren and his incredible work. We had just gotten we kind of cleaned it up and got the Unicode string, just the dependency from the Microsoft documentation, but then the structure for the peb loader data, the peb, the other loader data table entry, and all this stuff, we could give that to Binary Ninja so it could more smartly figure this out. If I copy and paste all this back in Binary Ninja over on the left-hand side, kind of like Visual Studio or whatever VS Code, where we've got these icons to get to different things. The type section, if I right-click any part of this, we could actually create types from CSource, I, and that hotkey. Now, if I were to paste this in, fingers crossed, we've kind of cleaned that up, made it smarter, and given all the definitions for these structures and types. I can just click Create, and fingers crossed. Okay, already a type called ulong. Yeah, that's fine. We can overwrite that. Yes. Okay, seemingly good. Now I could try to retype our var 3f8. And let me do that with that Y hotkey. That should be the loader data table entry and an asterisk with a pointer there. So if I do this, cool. Now we should be able to see the base DLL name being loaded in, and I do want to double click this refresh just to make sure it is going to do all the analysis that it can. Kind of handy though, now we could actually see it's going to end up getting the base DLL name. We could, if we wanted to, hey, define these as parts that we might like to use later on in our code, but it'll loop through this and actually check the length, do some interesting tests down below that are actually going to end up being, I don't know how well you could see this, a too lower implementation, because it actually goes through and ends up taking, if the value that's kind of interpreted as an ASCII number is going to be greater than hex 41 and less than hex 5a. If that's the case, it'll end up converting or adding hex 20 to it, which if you look through the ASCII letters or characters 0 through 255, that actually just means we're going to take what might be an uppercase character and force that to a lowercase character. So it's a too lower implementation. If you wanted to, you could hit the semicolon on this to add a comment in Binary Ninja. You can just say too lower implementation. That's good for our learning, but we will see this over and over and over again because they are now going to do some peb walk, peb crawling implementation to track this down. But they do this in a very interesting way because they actually end up trying to get, as I mentioned, kernel32.dll as one example for a DLL to load functions out of, but they're actually going to do this for other DLLs just as well. And they refer to them all not by, oh, the ASCII representation of like the string kernel32, but by a unique and specific hash or a hash ID that's coming together from their own hashing algorithm that they use throughout this. And we can actually see that in this for loop right here, which maybe we could try to analyze. We do test with an iteration for loop I equals 0, I less than var 448, and we saw that defined up here at actually 3a0. 458 brings us to, oh, another piece that we're all working through. So some length, right, for the string that we're going through. That is literally, as you might be able to say, the length of the string that we're specifying for a name of a DLL like kernel32 or what have you. We could actually rename all this to be like MW string length. That follows down, we can do MW length because that's set to it all just as well. Now, when I go see this, we could see that that's what we do over and over and over again. So for each character, we actually try to get information from a data structure. If we double click on this, there's a lot of nonsense there, but that's actually going to be a big list of, in fact, hexadecimal IDs, really, stuff that we'll be able to determine because they do some math here where they add in what would be the ordinal value of a given character 428 being the index that we end up using here. XORed, you can see the caret symbol here with var for F8 underscore 2. Shifted to the left 2 bytes, 2 bits, forgive me, also XORed with var for F8 underscore 2. What is that one? Okay, that is what starts with our hash, or like the hash that we're generating. So let me try to rename that like hash value, MW prefix. And this is really hard and tough to say out loud, so forgive me. But that is obviously going to be some hexadecimal value. If we know that the data that's represented here is supposed to be a list of these that is being accessed because it's indexing at all of this, we're seeing it plus to add that value moving through the array, we could try to retype this. So with all that said, let's change the type of this data block, as we know that that's really just going to be the hex values like uint32t, right? So Y on the keyboard, let's change that to our uint32 underscore t. And now, fingers crossed, if we hit accept on this, it'll analyze it, change this up, and it'll look like it's actually indexing. You see these square braces kind of just denoting the very beginning and end of this. So now we've lost the shift to whatever left 2 bits, but now we're still doing this with a shift to the right 8 bits. And there is actually one more tidbit we can add to this to help make this even easier for us. And this probably shows a good learning lesson for when you should kind of always be back and forth between, sure, the pseudo C that we like to read because it's easy, and maybe just the pure disassembly. Because if we were to actually kind of split the window here, let me try to split pane horizontally so we can get something on the right and something on the left. I know this gets a little bit hard to read with my face in the way, but over on the right one, let me say that I'm just going to click in on that very exact line where we are indexing from that data buffer to determine the hash value in the loop. But if I move this over to the other side, and if I were to say, okay, show me the disassembly here, you can see I'm at that instruction. But if I kind of take a look just before all this, it is going to end up indexing and working with all this stuff from EAX. But EAX is what ends up being worked with just previously, actually coming from ECX. And ECX is ANDed with hex FF, which means it's going to only be within that bounds of hex FF or 256, right? So if that's going to be the component that's really used to index out of the data buffer, it's probably pretty likely that our data buffer going all the way back down here is really at a length of 256 entries. So let me retype that one more time. We know it's uint32 underscore t as we've added, but now let's actually supply the length 256. So when I accept and hit enter on this, now we've got that analyzed, a little bit smarter to index this, and if I actually double click on this, it's a heck of a lot easier to read, and this is much more clearly all these ID values that will match a hash for what we could be looking for in the hash algorithm to determine a DLL name that we could import, as our malware will do what it does, and then later maybe a function name or method that we want to call out of that DLL. So this is awesome. This is data that we could use, and we could actually recreate the hashing algorithm and then determine what is it going to do and what is it going to load all throughout the rest of this code. So totally, we want to go copy all this and then start to work with it. So all the way from the top and the bottom, what we could do is copy. In fact, copy as CArray is probably best. 32-bit elements, little endian is what we're going to be looking for. Now I can get back into Sublime Text and let me open up a new script where we'll actually start to write some Python code. Let me save this. Let's just make it a .py file where we could build out our hash checker.py. Good. And we could change this to an actual list in Python. So let's remove some of the C-like syntax and make that just a hash table equals. And now we basically want to build out the same capability that they did with the hash function. where if they were given a string, remember an input string for a DLL name that they were trying to find, like just for an example, let's say DLL name can equal kernel32.dll, and let's define get hash ID given a name, right? String name, whatever. Of course, this is where you saw that string name dot lower. Remember, they had that toLower implementation. Not super necessary for us as we're starting to play with this, but they looped through every character in that string name. And they took the ASCII value, which was the ordinal in Python, ORD function we could call. And if we look back at what this was doing compared to the C syntax, going back down to the for loop for our hashing implementation, you can see that they grab that value, they XOR it with a hash value, and that's the current hash value that they started with hex FFFFF whatever, but then they end up working with it throughout because they're updating this, and then they change it and reset it at the very end. So that's all stuff we should know. Let's build that out. Back in our Python code, let's say hash value equals hex FFFF for Fs. And then inside of the loop for the character, we grab its ASCII value, we XOR that with the hash value, and remember this is going to end up being an index from our hash table, right? They do index that just as we've seen here, and that is going to be then XORed with the hash value bit shifted to the right 8. So do that with the hash value, and let me move this up to make sure you can see it. Hash value bit shifted by 8, and that should be the new hash value. Everything that returns is going to be that. Back in Binary Ninja, we see we just increment the character. We don't need to do that in Python because that's already been done for us. But in the very end, we do the hash value XORed with hex FFF all over again. So I think we can add that at the very end, right? Let's return our hash value XORed with 1234, 1234. So can I now try to get the hash ID for our DLL name, kernel32.dll. And if I print this, oh, broke everything. I have an error. List index out of range. Oh, that's the hash table tidbit here. Binge is not showing me that because it probably doesn't need to, but that is still ANDed with the hex FF, right? That's to only say, look, we're only going to get something within the range of 256. So let me update that to everything in this index inside of the square braces. I want to make sure that that has another AND hex FF, right? Let's try to print this. And let me build view this in the current page. So you should still be able to see this as a value. What is that in hex? Can I run that? 6AE69F02, that looks a little bit familiar because that is exactly kernel32.dll that they try to load first. Cool! Okay, so we have just recreated that hashing implementation, and now we could track down not only the DLLs that they load, but now all of the functions that they will reflectively walk through with this pebcrawl. And we could see this kind of just honestly ignoring or abstracting a lot of the stuff that they do later, because we'll see this process again and again, now with a new hex value. But this is where we could do something really kind of interesting, because if we were to say, okay, kernel32.dll, I know even just, I pulled that example out of thin air because that's just what we're used to with load library and all these examples here. If it's trying to grab some other functions, it would be worth knowing what the names, literally the string representation of all the other potential DLLs are, and then the functions that could be called from that. Now this is where some of our sweet friends over at Malcore can come in handy, because they have helped put together an awesome resource for exactly this. So let me say big shout out to Malcor. Seriously, genuinely, this is pretty cool, and I hope it's a good resource for others as we are trying to learn and walk through this process. But look, these are all genuinely, literally strings for DLLs that could be loaded, but then all the methods or functions that could follow. So this could get kind of crude, a little bit scrappy, but if I were to look for kernel 32, if I could type correctly, there it is, and that could very well be the hash that we might end up working with, and all of the functions that could come through and follow that. So if we were to use this JSON file, common_dlls.json, we could take our hash checker capability and give it a little bit more instrumentation to now look up, based off any DLL name that we want to look for, what is that hash? Let's minimize our getHashID function here. DLL name isn't super duper important, but if I were to open, so let me open that common_dlls.json, just read as bytes, doesn't matter. We can do that as file pointer filp. Honestly, we don't need the mode here because we just want the file pointer, and if we were to import JSON, then Jason, our good buddy, could totally help us load that filp file pointer. That will determine that as the DLLs that we actually will end up reading through, and given that, we could look through every single DLL, like DLL name in the DLLs. And note in that JSON file, they don't actually have the .dll suffix, but we would want that because that's what we built out for our implementation of this getHashID function. So DLL could equal DLL name plus .dll. Stupid and dumb, but that works. And we could generate the hash. Like we could just simply say the hash of that DLL is getHashID given that DLL, and check if the hash is something that we want. Like maybe we're looking for a target, like target hash ID is probably a fine name, and that was something that we started with going back to Binja, right? 6 this, we could copy that value. Knowing that that is kernel 32, that should be all that we need. Let's add that variable there. If that's the case, then we can print the DLL and like a found appropriate DLL, adding that. And then we can loop through all of the other functions in that because we know, okay, they're probably then going to, after they've loaded that specific DLL, now call a specific function within it. We can say for each function in the DLL's JSON data, given the DLL name that we're looking at, now get the hash ID of each of those because it's all coming from the exact same lookup table. Get the hash ID of each function. So we can say the function hash will equal that, and then let's actually print out each function name and the hex value, just as we've seen above, of the hash that we've calculated. So with that, we could totally build out, we could do like an else statement here just as well if we can't find that. Could not find DLL module mapping to ID. Now we have this given capability to get not only a target hash for a specific DLL that we're looking for, kernel32.dll in this case, but then we'll see what all the other functions will correspond to, and we can just kind of map back and forth. Oh, did I break something? Yeah, I broke something clearly. Oh, the else statement doesn't need to happen because that we could do that after our for loop, right? You can do a for else just in case we never find anything. We just won't care about that line, but now we do clearly see all of the functions that will be called given a hash ID, knowing that we did see that in kernel32.dll. So here is where we can put this to the test. Let me copy all of this data, put this in a new buffer for us, and let's say that in Binja, we know kernel32 corresponds to this 6AE value, that hash ID that we've uncovered. Scrolling down, we'll see it now trying to work through the same for loop implementation and trying to determine what would be 906A whatever. So if we copy that hex address, now go determine, not an address, but an ID value for us, right? Our hash, that corresponds to create thread. That is the function that we know it's reflectively pulling in and grabbing thanks to that kind of process here and the peb walk that they do. very, very cool, because now we know that we've determined this, actually been able to pull it down, grab that value, and ultimately inside of this condition, we know, let me rename this to our MW create thread call. We can hit accept on that, and then see it's built that out, and now we're going to do this over and over and over again to go grab other functions for it to use. We can see another kernel 32 instance that we end up using. Scrolling down later, we go determine. It's going to grab this hex value, so we can copy that, get back to Sublime Text, look for that. It actually gets sleep from kernel 32. Okay, MW, let's rename, and to change that, our MW sleep. And we will go through this process over and over and over again, but look, at the very end of this, we are getting to another create thread where we see it move to another new subroutine. So it's going to invoke something else, but if we jump over there, we do more peb crawling, peb walk, and we see this over and over and over again. So I'm gonna be honest, I'm gonna walk through this process, kind of speed it up, and then I'll let you know how far we can go. But now we see the alloc console, rename this just as well. You get the idea, so let me cruise through this. And I know it's a manual method. We could absolutely, without a doubt, do this in an automated way with Binary Ninja or some of our other tricks. But I do want to show you this process and tell you, really, that's all I'm doing right now. We've got this ironed out, where I'm just going to end up looking for changes to when we get to new capabilities for imports, and then if we see a different hex value rather than our 609 whatever for kernel 32, we just swap that out in our Python script, get a new lookup table for us, and then we keep cruising. Ooh, actually, we do get to a new interesting part where we start to see some pieces of data that look to be encoded, or at least in their hexadecimal representation. You can see the \x prefix over and over and over again. But these are pretty clearly, as we can see within Ninja, Binary Ninja showing us, hey, we have this variable stage var1a00, but another that's just below it, var_22e0. Seeing these two together, we tie them and end up getting these XORed super easily. So what we could do is, again, super small, simple, copy this value. Let me copy as I believe, hex dump. Oh no, raw hex, forgive me. Raw hex will just give us the 6C9A E5, the values without the \x in the mix. So let me hop over back to Firefox, where we were working in CyberChef just previously, because now I could paste in this hex value, and we know that the key, or the operation that they do the XOR with, is just the other value. So I could right click this. Let me make sure to copy the correct value, copy as the raw hex once again, bring that and use that as the key. And now you can see in the output something a little bit more peculiar, real data here. Now, this specific string has a very unique and special use case that we might be able to talk about later. It will determine how long this video is. I think this is already a ginormously long and lengthy video, so we'll see. But we'll see this pattern again over and over and over again as just data that we could XOR out pretty simply. I do want to keep cruising to see what they do next for their peb walk. We can see a couple other cases that they use the process environment block to see other functions that they will import and work with. Oh, looks like there is a new ID. So again, we can just use this and go put that in our Python script to determine a new target ID and see if that will give us a new DLL that it loads. Yes, looks like there is one. So let me go bring that into another tab, and we're actually looking at NTDLL and all the functions that could be included in that. Follow along the exact same process. Oh, they do some interesting stuff with NT-allocate virtual memory though. You can see this then actually being used just below, where they do create some memory that they can work with and actually write some machine code in it. And I won't drag us down the rabbit hole, but this is actually really clever, and we'll see it used later on, or at least we know that it will be used later on, and we get to the rest of the implant here. But look, they use NT-allocate virtual memory to stage some data where they actually write machine code that ends up being a hook. Like a function hook to trampoline to new code execution later on that will be the actual detonator for stage 2 that actually writes this address to end up putting the capability that will be used in the real program that we'll see later down the line. But just note, this segment is actually a little bit spooky. They do write a genuine function hook here to run the real payload super duper soon. The strange string that we saw earlier from that XOR operation, remember our new from UTF-8 string, that is used by the real program that we see affected later on. And that is genuinely a hook for that function, all with some cool, clever, unique NT-allocate virtual memory. And later on, when we see some other PEB work, they will protect that memory and do other shenanigans with it. Here's that NTDLL one, and we could see another copy or a hex ID that we could use. Show you that in Python. We'll go now find that NT protect virtual memory. Scroll down, and I'll continue that process again. Oh, we do get to the very end here, though, and we start to do more NT-allocate virtual memory shenanigans, so making a little bit more unique, special stuff. But then we invoke something with some more data. How does this happen here? Basically setting some data buffer that looks empty to start to a variable var 2900, and then that is going to end up being the result that's returned. But how did that happen? It's all seemingly zeros to start. So what is this var 2900, where does this come from? Let me trace that back, scrolling way up. We could see it in the cross references in the bottom left, but that might just jitter us out of where we were. So I'd like to kind of see, is it in this function at all, even to start with? Let me just do some manual scrolling. And yeah, it looks like it is where, oh, interesting. This is used with the syscall opportunities and the NT-allocate virtual memory, the stuff that it writes. Oh, that's building a legitimate address, though. But we know that this is used at the very end of this function, and they don't do a whole lot else with it. It is seemingly executed, though, or brought to life. That is going to be a static address written to this buffer, though, that data 18001A140. So if we wanted to be a little bit lazy, but still more accurate in this, we could hook up our stage 2 DLL to a debugger and see what value is going to be written here when we actually execute this. Do some more dynamic analysis. That does mean, though, that we'll need to go through that 010 editor process again to disable ASLR and kind of work through that again. We can do that super quick, though. Let me go ahead and open up our stage2.dll. We'll work through the very same process with the NT header, optional header, bringing that down to the DLL characteristics, and the dynamic base, we'll set that to 0. Save that file. Back in x64 debug, we could just go open up our stage2.dll. We know our first breakpoint should be fine, so we can run this. But getting back to Binary Ninja, we know that this line is when that data actually ends up being modified and is set. So we could get this address. Let's copy that address. And then back in x64 debug, let's try to Control-G to go to that address. There we are. Now we can set a breakpoint there. Should be F2. Now let's continue up until that position, and we should now be able to see the data at this address is going to be filled with something. So let me double click in here, grab this address, and then we can see that in the dump, way down the bottom left of Hex64 debug. Control-G once again, we'll hit enter on this. Now this is all zeros at the moment, but this line is the one that does actually set the value there. So the address will be populated, and if I step over, I believe is F8, there we go. We can see a new place set. And actually, a little bit interesting, just as we
Today's video is brought to you by our friends over at Brilliant, ladies and gentlemen. Do you want to actually learn something new in the fields of mathematics, data analysis, programming, or even artificial intelligence in a fun, actual, effective way that'll stick with you versus just trying to memorize everything? Ladies and gentlemen, Brilliant is a learning platform designed to be uniquely effective with actual approaches that are designed with lessons built from the ground up. So whether you're somebody with actually no expertise in a topic or you're somebody with some advanced level of knowledge, you will always be able to learn something new in a method proven to be 6 times more effective than just watching lecture videos on the internet. Plus, all the content on Brilliant is created by an award-winning team of teachers and professionals from MIT to Caltech to Google to Microsoft and so on and so forth. And of course, if you're talking about problem-solving skills, that is an absolute must. Not memorizing, something that you'll actually be using to build real knowledge on specific topics. So not only will you learn how to do these topics, but you'll also be a better thinker. And of course, if you want to learn a little bit a day or a lot, that'll actually help build an important habit. So whether for personal or professional growth, you can build real knowledge in just minutes a day. And of course, Brilliant makes it incredibly easy to learn right on your phone, with fun lessons that you can do whenever you actually have the time to fit them in. So whether you're diving into something brand new or taking a quick practice session, literally it takes minutes to actually evolve your knowledge. To try everything Brilliant has to offer for a free full 30 days, check out brilliant.org/SOG or scan the QR code on screen. And you will also get 20% off an annual premium subscription. That said, let's get to the video. July 6, 2016 is when Pokemon Go finally made its rounds into everyone's smartphones. Now back in the day, you might recall a whole bunch of people running around, capturing Pokemon, setting up lures, having literal turf battles with each other over the real world, playing with Pokemon on the go. Now, Pokemon Go, ladies and gentlemen, is quite literally an augmented reality, Pokemon game where you actually go into the real world, walk around, and capture Pokemon. It basically works off of a in-game map that is reflected off of your actual real world where you walk around or geolocated, and you can play with other players, you can explore by yourselves, and on the surface it seems like a pretty harmless game, but it's a game that actually has a fair level of controversy surrounding it. The government of Bosnia back in 2016, around the release of the game, warned people that they shouldn't be walking into actual minefields. Translating their press release, they said, "Today we received information that there are cases where users of the Pokemon Go application in Bosnia and Herzegovina enter mine-suspected risky areas in order to find Pokemon. All citizens are requested not to do this and to respect the mine danger signs." I'm just going to say, dog, if you're walking around in a minefield looking for digital Pokemon, then maybe that's just natural selection taking the course. But one thing that isn't actually laughably funny here is Hamdi Bahit, a member of Egypt's Committee of Defense and National Security, actually told the parliament there that Pokemon Go is the latest tool used by spy agencies in the intelligence war, a cunning, despicable app that tries to infiltrate our communities in the most innocent way under the pretext of entertainment. But all they really want is to spy on people and the state. Now, that's a pretty big, serious claim, and it's one that actually Niantic has had to try and refute and actually outright deny that it was actually, used as an espionage tool. A spokeswoman from their actual company ended up denying the allegations that the game is a tool of espionage, and even said the company asks all users to abide by local laws and respect the locations you visit and the people you meet during your exploration. Which obviously any company is going to say. I mean, who the fuck would actually say the opposite of that if they want some good public relations? Now, the Pokemon Go CIA conspiracy is not exactly something that's entirely new. 9 years ago on the Pokemon Go Reddit, which, my god, does time actually fly, Pokemon Go and the Central Intelligence Agency. So you all know the company that made Pokemon Go is connected to the Central Intelligence Agency. Not kidding. I know it sounds like typical conspiracy bullshit, but you do your own homework, which don't worry, we will in this video, and trace Niantic and its CEO, John Hanke, who funds his projects. It's right there. But if you're comfortable scanning your surroundings in high definition for the CIA and Google, by all means continue feeding the AI its deep learning material. So this was a conspiracy that came out that if you were actually using your cell phone and walking around, that you were capturing images that would be sent to Niantic and immediately help the CIA. Well, part of this conspiracy theory actually ended up getting completely proven. And who ended up proving it? Well, ladies and gentlemen, it was actually Niantic themselves. So one of these actual posts that came out about a few days ago, November 12th of this year, they said they were building a large geospatial model to achieve spatial intelligence. So basically, by going down over here, they kind of describe that when you look at a familiar type of structure, whether it's a church, a statue, or a town square, it's fairly easy to imagine what it might look like from other angles. Even if you haven't seen it from all sides, as humans, we have spatial understanding. That means we can fill in these details based on countless similar scenes we've encountered before. But for machines, this task is extraordinarily difficult. Even the most advanced AI models today struggle to visualize and infer missing parts of a scene or to imagine a piece from a new angle. And this is about to change: spatial intelligence. So what they basically mentioned was Niantic's visual positioning system, which is a VPS, has been trained on 50 million neural networks, more than 150 trillion parameters, enabling operation in over 1 million locations. So this will help computers perceive, comprehend, and navigate the physical world in a way that will seem equally advanced. So analogous to the LLMs, stuff like ChatGPT that you're using, geospatial models are built using vast amounts of raw data. Billions of images in the world, all anchored to precise locations on the globe, are distilled into a large model that enables a location-based understanding of space, structures, and physical interactions. Now, where does all this information, this raw data, come from? Well, if you've been following, ladies and gentlemen, it probably comes from a whole bunch of applications Niantic has built. So if you look at Niantic's history, some of the games that are available right now are games like Ingress Prime, which came, from my understanding, before Pokemon Go. But Pokemon Go and Monster Hunter Now are two gaming-themed versions of Niantic's mapping software. So any of the actual data that has been gathered from Pokemon Go or Monster Hunter Now could, and most likely, from my understanding and my personal belief, was used in actually assisting this company build this crazy geospatial model. So with 500 million downloads just on Android, that's a lot of data to be grabbing, okay? And not only are we looking at money that obviously they're making, Nintendo is making, the data that they're allowed to grab, let's just look at the permissions for Android alone. So the data that this company collects obviously is photographs and video, which obviously if you allow Pokemon Go the ability to use your augmented reality feature, they can start looking at, the actual video, maybe even a photo as you're capturing the Pokemon. And of course, the further you go down, obviously each of those photos or video sessions are again connected to a location. Sometimes it can be approximate for analytical reasons, and obviously if you're playing a game where being on a map and geolocated at all times is a necessity, then having your precise location is the most important part, okay? So they kind of show that over the past 5 years, they were focused on building this VPS, and which uses a single image from a phone to determine its position and orientation using a 3D map built from people scanning interesting locations in our game. So they straight up say it's from their actual games. Like, come on now. So this is like a heat map of generally where information is grabbed. So all over North America, Europe, basically around the world. India, for instance, is pretty popping over here. Japan, all throughout like Eastern Europe. Parts of China, Australia, where people live. And of course, one thing they showed was the actual neural mapping as well. So to give an idea, they made this 30-second video to showcase what this works, so a 5-minute neural map. So learning an image from posed RGB images. So here they have a series of images from my understanding, and their neural map allows you to build an understanding of that location in this digital space. So again, that's kind of the stuff that they've been building. But Muda, how does the Central Intelligence Agency fit into this? So when I started looking up where the actual source of this big conspiracy was popping up again, I found that 5 days ago on boards like Kotaku in Action, it seems Niantic is using Pokemon Go as a means to collect large amounts of visual training data. They absolutely have admitted it, for topographic modeling and generative AI or other things. And this led me to a channel known as the Lunduke Journal. There was another post 4 days ago on r/Pokemon Go where it said in 2016 this was Lunduke's crazy conspiracy theory about Pokemon Go being used to spy on everyone, backed by the CIA. And now in 2024, Niantic Labs proudly brags about using Pokemon Go to spy on you and using that covertly obtained information to build a massive 3D artificial intelligence. Now, I don't think it's necessarily covert. I think anytime there's a free game, especially one that tracks your location and uses your camera, there's probably another ulterior reason that a company would provide you that kind of a game for free. Remember, if something is free, you're definitely the product. And if you think Pokemon Go makes these guys a lot of money, having the ability to map 3D locations from just fucking photos is some crazy level of tech that a lot of governments are willing to pay money for, especially the United States government. So I went to Brian's channel over here, and Brian, whose most popular video literally is 7 days ago, the Pokemon Go spying conspiracy theory, yeah, it's verified. So, this is just Brian's assessment, and this is Brian's words saying that this is possibly just the CIA or some spying conspiracy that's occurring, right? But anyways, how do we connect Pokemon Go to the Central Intelligence Agency? Well, this is where we have to look at the history of the company. So you have to go all the way back to 2001 in this situation, and you have to basically embroider yourself in something known as Google Earth. So for anybody that has used Google Earth, you probably know that it's the amazing software that allows you to basically examine any location in our world. So for instance, do you want to see how Tokyo looks instead of just your standard mapping software? Well, you can just zoom right on in. And in fact, some cities have so much information provided that you can zoom literally into any point and get almost a 3D representation of what the roads look like, of houses. I mean, this is some crazy, crazy shit. Now, you might be like, well, Nuda, why are you bringing up Google Earth now? Well, Google Earth, ladies and gentlemen, actually has ties to Niantic. So you might be like, where did Google Earth come from? It wasn't actually made at Google, ladies and gentlemen. No. This actually was developed by a company known as Keyhole Incorporation. Now, the thing about Keyhole is they actually did have software that you could actually use. Now, this was something known as Earth Viewer 3D. So that image of Tokyo I showed you was cool, but obviously this is what it used to look like all the way back in like the early 2000s. Obviously not as granular, not as impressive, but getting an idea of satellite imagery connected like this is still mind-blowing to anyone. And obviously this was connected to the internet, so you have to launch a client that looked much like this and basically use their servers to get access to, again, this kind of 3D information. So the guy behind it, John Hankey, for anybody that doesn't know, worked on, I believe, Google's like geo products, so stuff like Google Earth, Google Maps, Street View, all that stuff was basically the brainchild of this individual right here. Now, the technology he made with Earth Viewer was so popular that apparently big publications, big news agencies like CNN, CBS, were basically using it to cover the invasion of Iraq, right, back in 2003, where basically they would use their 3D like mapping imagery to do these flyovers. Because obviously, guys, they're not going to be sending in like helicopters and shit to an active war zone at the time. So they exchanged some attribution, but they found out that it was basically so popular that trying to upkeep the software and keep up those server costs, they weren't actually able to make it happen. Even though they made actual deals with Nvidia, Sony, they literally were unable, because of server costs, to keep this thing running for too long. And not only that, you also had employee turnover to worry about, so it was actually kind of a fucking financial nightmare. I mean, you made something that's really popular, it just wasn't monetized properly. So literally it was this stroke of luck that caused an actual agency as the Central Intelligence Agency to pay closer attention. Now, you might not know it at this moment in time, but a company known as IQT showed up at their doorstep and basically said, hey, you want some money, pal? You want to get that little cash infusion? Well, IQT, for anybody that doesn't know, if you go to their About section, they're pretty honest about this. They are actually a CIA front, so set up in 1999 by the CIA as an independent, not-for-profit strategic investment firm. We spent a quarter century, 25 years, building unparalleled expertise that we draw on to help startups adapt their highly innovative products. So what kind of products have these people fucking invested in? Well, the CIA's IQT nonprofit agency has put money into groups like Skydio, Capella Space, Bounce Imaging, Rocket Lab, Mersive Technologies, and FireEye. To give you an idea, for space alone, they gave these people money because they give them clear, and timely satellite imagery. High-resolution stuff that I'm sure the CIA uses for really good reasons, and also when they need to get good critical analysis of whoever they're targeting for whatever shady reason they need. Now, this isn't a state secret. Like I said, this is something that happens, and this is something that is pretty much available, and we've talked about it in the past. And it's not like it's the only investment they've made. They made 750 plus investments in companies all across Asia, North America specifically, and Europe as well. And in tons of fields, whether it be life sciences, the cyber field, AI, space, they put tons of money at companies that get their attention. Basically, if you're in any organization that is in a specific group or you're analyzing data or capturing these high-resolution space images, you've probably been contacted by these guys at some point, or at least they're following you and shadowing you at this point. It's fucking creepy. So back in 2003, in order to assist this organization, In-Q-Tel decided to actually have a strategic investment in Keyhole, as they mentioned in this press release that I dug up through the Wayback Machine. So immediately demonstrating the value of Keyhole's technology to the national security community, NEMA used the technology to support the United States troops in Iraq. So within 2 weeks of their engagement with Keyhole, we implemented the technology to support our missions within the Pentagon. So chances are, if you were somebody working for, a terror organization in the middle of somewhere on the other side of the world, this software was used to map out your village, map out your home, or, the surroundings of it, and basically assist the US military in how to take your life in a matter of minutes. It's kind of insane how much money gets poured in to discover quirky, unique, safe ways to kill our enemies across the world. If you ever get wilded out about investments like this, remember there's an entire military-industrial complex that has existed for decades, siphoning billions of dollars from the United States governments to develop new weapons, new technologies that ultimately are used to destroy people all over the world, and sometimes, if we're lucky and there's a bit of morality surrounding it, maybe that technology gets trickled down to maybe better our lives in some cases. It's kind of a double-edged sword. A lot of good stuff gets made, and a lot of quirky ways to kill people or spy on people gets discovered as well. So at some point down the road, in 2004, Google ended up actually buying Keyhole for some undisclosed sum, all right? It certainly wasn't cheap. Now you might be like, Muda, why would the CIA even allow a sale like that? I mean, they punched in money for this organization, but I actually believe when it comes to In-Q-Tel, anytime it's a US company purchasing something, that usually goes through. It's not as if it's a foreign adversary or a foreign national purchasing access to technology the CIA has sort of invested money into. Remember, strategic investments are not made for financial boons. They're made so that the technology can be used at some point down the road for operational reasons, and you can imagine why the CIA would need mapping software that's that good. So why would Google want Keyhole? Well, they found out that apparently in Google's world, 25% of the search traffic at the time was all relegated to people looking up route planning or maps. So they figured, hell, we've got billions of dollars, why not buy the best goddamn mapping software in existence? Shit, that's a great idea. And then hopefully roll that over to things like Street View or just Google Maps. Now, back in 2010, it was actually formed as a company, an internal startup within Google itself in 2010. So Niantic effectively is a company that belongs entirely to Google, right? Now, Google used to own this for like 5 years, 2010 to 2015, until obviously 2016 came by. And, they basically split and became their own individual company. But they ended up actually getting a shit ton of funding from Google, obviously, Nintendo, and also the Pokemon Company. Like, we're talking millions upon millions of dollars ended up actually going to this organization. Now, one of their first games was Field Trip, then they made Ingress, and then Pokemon Go, and obviously a whole bunch of Nintendo-themed games, until finally they released, like, Monster Hunter Now. So they've made plenty of projects, but a whole chunk of these projects are obviously designed to be used with this live mapping feature that they have, constant photographs that are probably being scanned and grabbed from your devices, all themed underneath these big budget, these most iconic video games. So things like Pokemon that millions, if not billions around the world might actually download. I think billions is a bit of a stretch. I know that Pokemon's huge, but especially when it comes to mobile gaming, you really have to look between like millions, hundreds of millions, maybe over 1 billion users, which no matter how you cut it, it's still a lot of information that these people can end up actually grabbing. So look, at the end of the day, right, with all of this considered, tons of applications that are free are ultimately designed to gather information off of you and use that information for reasons that actually assist the company beneficially, right? Like financially. So when it comes to, you downloading anything free, whether it be a social media application, a game, even if it's some innocuous software where you download, it, you send it and generate memes, AI generated or enhancements or pictures or whatever, all of these software, if they are free and they're gathering data off of you, that means you are the product, and the data you generate or the data you provide is more beneficial for them to grab and maybe use for something like this, like exactly what Niantic was doing, which is building this, large spatial model that they can then sell to big companies for really important reasons. Now, obviously, I can't confirm that the CIA is really behind any of this. It's just a weird link between these organizations. But to give you an idea, if the CIA was so interested, and this is just my personal analysis, if the CIA was so interested in a 3D mapping software that, again, they could use to basically serve as aerial scanning, for organizations like this, imagine how useful a software where you can basically build a 3D map, a spatial map based on photographs, and have an AI basically realistically build a 3D environment that you could then use to, again, plan situations better, maybe place, 3D operators inside and plan those situations. Again, really awesome. Maybe people could use it as a sort of game or demonstration of how to perform an actual operation. I think that has real value to not just the Central Intelligence Agency, but plenty of intelligence agencies around the world. I think that has plenty of applications in the US military. If you don't see it, then honestly, you probably need to broaden your horizons a little bit. So yeah, I can see the value of this kind of stuff. And ultimately, it's that value that allows me to kind of look at this conspiracy theory with at least more believability than something like, I don't know, the fucking flat earth, for crying out loud, right? Like, this is something where, again, if it came out in 10 years that the CIA used any of the software developed by Niantic to assassinate some fucking person, despot, terrorist, world leader, cartel boss in some part of the world, I would personally not be shocked in any capacity. Ultimately, the people involved in this kind of software all have backgrounds to super spy programs, the CIA investment firms. So honestly, seeing what, Niantic released in that press release is not something that really shocks me. What they were doing was building a massive artificial intelligence that has actual practical applications well beyond gaming off of the backs of free information provided by the average person. So anytime you play Pokemon Go or Monster Hunter or World Go, whatever these games are called, you have most likely contributed to a 3D map, a 3D spatial engine that is now probably being used for features and actual services far beyond gaming. And if a military pays money to tap into that, for again, logical reasons, logical applications that benefit them, it shouldn't really shock you. But to say that this was spying in the sense is a little dubious. I don't think this is spying as much as it is people need to understand that when you're using free software, you are always going to be the product. And honestly, if Pokemon Go scares you with the CIA, I would actually say you should probably be more afraid of mapping software in general. Like, imagine the amount of information that the government could gain off of mapping software, patterns, and analysis based off of that. Imagine if this is how scary Niantic is going to be. Any other software where, again, you're providing images to generate memes, or you're actually providing them for AI enhancements, what's happening with that information that's processed on these servers that you don't know are actually deleting or wiping your information after the use? I mean, these are all things you have to consider in an age where free software exists by the goddamn boatloads. Who's involved in your software? Who's using it to track? Who's using it for nefarious reasons? And who's using it for even positive reasons as well, too? When you upload or post anything or share your location, you have to understand that it's not just going to the company that's developing your game. There's obviously going to be other technologies used in that software that are also going to be peeking into that information as well. And if that doesn't kind of freak you out a little bit, then I actually kind of envy you. But yeah, the Pokemon spying conspiracy, I wouldn't really say it's actually spying. I think it's more that this is free software, and ultimately, Niantic, over the course of the last several years, has gotten so much information off millions of users that they were able to build this crazy artificial intelligence with a data set that literally any company could actually fucking dream of. Now, is this software being used by the Central Intelligence Agency, or do they have access to it? Honestly, I wouldn't be shocked, but I'm not going to sit here and confirm a conspiracy theory that I actually cannot. Would I be shocked it's real and true? Not at all. But ladies and gentlemen, that was a deep dive into the Pokemon Go CIA conspiracy. So the next time you want to hunt your Pokemon on the go, maybe, just maybe, think about where that information could really be going to. If you like what you saw, please like, comment, and subscribe. Dislike it if you dislike it. I am out. Hello, guys and gals, me Mutahar, and ladies and gentlemen, today's going to be a fun little video about technology and how the government wants to destroy Google, at least when it comes to Google Chrome. Now, you might have heard the words, the government is forcing Google to sell Chrome. You might be wondering, how the heck are they going to do that, ladies and gentlemen? Well, to understand all of this, we're going to have to bring you up with some context. We're going to have to bring you up with what has been going on. In the last several months, if not the entire year, since 2023 has basically begun, and also even before that, there's been a massive amount of lawsuits that have kicked up, known as antitrust lawsuits. Now, if you know anything about big tech companies, they make a lot of money, and they're pretty much some of the biggest companies that anybody has ever seen in the history of time. But not only are they big companies, the products that they actually hold have so many users using them that it's almost difficult for some random person to jump into the market, whether they be the smallest business in the world or an equivalent mega corporation. It's impossible to jump into any business and compete with some of these entrenched products. Like, imagine YouTube.com. How many other video sharing websites do you know that even come close to YouTube.com? I would actually wager it's 0%. There are other alternative video sharing websites like Rumble, Odyssey, so on and so forth, Dailymotion. You've probably heard of former competitors like, I think it was like Vidly or VidMe or things like that back in the day. But ultimately, YouTube.com is basically the video sharing website to go to. It's where most of the world goes to watch any form of online on-demand video at any given time. So yeah, it's clearly huge. And also, when it comes to a lot of these big tech companies, anytime you're entrenched in a specific market, you're pretty much gonna be there for a while. Now, in the last couple months, you probably noticed that I made a video about Google basically being declared a monopolist. Now, in the United States, monopolies are completely illegal. You can't run a monopoly, and there's plenty of laws that are centered around it. Like, for instance, one of them is known as the Sherman Act. And if you read the Sherman Antitrust Act, just a quick little idea is it tells you the law prohibits conspiracies that unreasonably restrict trade. Under the Sherman Act, agreements amongst competitors to fix prices or wages, rig bids, or allocate customers, workers, or markets are criminal violation. But it also says the act makes it illegal to monopolize, conspire to monopolize, or attempt to monopolize a market for products or services. An unlawful monopoly exists when one firm has market power for a product or service, and it has obtained or maintained that market power. So to give you an idea why monopolies are bad, just a quick example. Imagine in the world of video gaming, Microsoft just bought every single video game like developer, publisher out there. All of a sudden, they bought basically the entire industry right there because they had the money to do so. Microsoft is substantially richer than Nintendo or Sony. If there were no competition, if there was no anti-competitive laws, they could basically buy out every single developer and make them develop exclusive games for the Xbox console, basically snuffing out their competition right there and then. Now, if all of a sudden the only player in the video game console space was Microsoft, then they basically get to dictate how the entire industry goes. They design the hardware, and they can basically make you play on the same box for 20-something years, right? If they control an industry, then they basically get to decide where it goes. And to give an idea, recently, very recently, Microsoft got hit with regulators not just in the United States when they tried to purchase Activision Blizzard, a pretty massive player in video games, where they were producing titles like Call of Duty, World of Warcraft, Diablo, massive games, at least Call of Duty, that is played across numerous devices, numerous consoles. So the government didn't appreciate Microsoft just spending billions of dollars and buying out entire game developers and publishers that clearly their competition couldn't. And this is when the market jumps in to regulate a space when they detect that there's possibilities of a monopoly brewing. And Microsoft doesn't want to deal with it. They've got a pretty bad history with that already. So this 286-page ruling, one exact piece that I wanted to actually bring up here and remind you was this page right here, was this mention. Google has a major, largely unseen advantage over its rivals: default distribution. Most users access a general search engine through a browser, so something like Apple Safari, or a search widget that comes preloaded on a mobile device. These search access points are preset with a default search engine. The default is extremely valuable real estate because many users simply stick to searching with the default. Google receives billions of queries every day through these access points. Google derives extraordinary volumes of user data from such searches. It then uses that information to improve search quality. Google so values the data, absent a user-initiated change, it stores 18 months worth of user search history and activity. So what they're effectively going with over here is, when you purchase an iPhone, for example, this is not a Google product. So if you decided not to install any application from the get-go, your basic web browser would be iOS's Safari. Now, the thing about search defaults is when you open up Safari and you basically go to the URL page and you type in any prompt and hit enter, it immediately defaults to google.com. So that default is worth so much money. In fact, it's worth around $26 billion in total payments, not just to Apple, obviously, but to pretty much everyone in the, tech sphere. Google pays around $26 billion to make sure that across multiple devices, they are the default. So in a case where you're not even downloading Google Chrome or any Google application, you probably are going to be defaulting to using Google. And that's so important for Google at this moment in time that they will pay a massive chunk of money. To give you an idea about how much money Google makes in its web browsing market, in its advertising space, in digital advertising through search engine defaults like that, we have to look at a graph for them and their competitors. So for instance, Google's ad revenue is calculated right here. So around $237 billion at one point, I believe in 2023. So again, ladies and gentlemen, that number keeps just going up. Now, when you compare them to their competitors like Microsoft, which is, again, clearly a massive company, you're looking at $12.2 billion. And that, of course, would be money generated via Bing search engine. How many people do you know use Bing? We'll get the exact number or somewhere close to it real quick. Then, of course, the next competition here is Baidu, and then Yandex coming in very much at the end. I mean, Yandex's revenue is literally an accounting error for Google at this point. It's actually that wild. Now, when you look up search engine market shares, the one thing that actually should stick out is the only double digit here is Google. So 89% of, again, the world, according to StatCounter and their examination, uses Google. After that, 4.15% use Bing. So literally, Microsoft search engine is like literally just a fraction of the amount of people that go visit Google, right? Then you've got Yandex, then you've got Yahoo, and then Baidu, and DuckDuckGo comes at a cute 0.69%. So basically, Google's competition literally isn't even competition for them. They're just tiny little specks on the radar. So it started from these lawsuits initially targeting things like digital advertising, and again, Google's dominance in that space eventually evolved into a set of actual wants that the government has brought forward, where they want to basically break up Google and the dominance that they actually have in the market. So this 23-pager, which we're actually going to look through, kind of opens up the insight as to what the government wants Google to do to get rid of their massive domination. So according to this, what they said was, for more than a decade, Google has unlawfully maintained its monopolies in general search services and search text advertising through a web of anti-competitive practices. As this court found after a lengthy trial, Google is a monopolist, and it has acted as one to maintain its monopoly over both the search engine services and search text advertising markets. So what they said was Google has manipulated its control of Chrome and Android to benefit itself. while sharing monopoly profits under conditions to induce third parties, so third parties like Apple for instance, across the ecosystem to help Google maintain its monopolies. Google's exclusionary conduct has, amongst other things, made Google the near universal default for search and ensured that virtually all search access point root users valuable queries and interaction data to Google. Google's unlawful behavior has deprived rivals not only of critical distribution channels, but also distribution partners who could otherwise enable entry into these markets. So Google is paying out so much money, and I believe at one point in one of these lawsuits they were talking about revenue shares, which again is just more, sweet stuff on top of the already sweet stuff that they're providing, cold hard cash, to big companies like Apple and Samsung in certain cases. So people that release really popular handset devices, computers, really anything people use to then browse the internet, these people have already made Google their default. So the people who are jumping into the internet immediately just use Google, and they really don't immediately go to other search engines. They may not even know other search engines exist, right? Like for somebody that's not super computer literate, if you go up to them, they probably will know what Google is because that's what they use. But if you ask them, have you tried DuckDuckGo? They won't even know what that is. They might know what Bing is, but generally when you get into the market, because literally like 1% of global users use anything other than Google, you know what I mean? Like these other search engines, like their literal market share is like 1%, if that. And even the act of switching defaults wasn't easy. I had to actually go to my search in the settings app for my iPhone, search under it, I swear to God, find the search engine setting, and then actually find only 5 other options to pick from, or just 5 total. So even in this case, you can't switch to certain providers that you might be a fan of. It literally just defaults to Google or whatever other options Apple wants to throw in. So what they said was the court's opinion described a decade-long harm Google inflicted on the market for general search and search text advertising. At the same time, it also provides a roadmap to the components necessary to restore competition to these markets that have revolutionized how we live. So to go over these roadmaps, let's exactly look into what the government is recommending. So for instance, Google's ownership and control of Chrome and Android, key methods for the distribution of search engines to consumers, pose a significant challenge to effectuate a remedy that aims to unfetter markets from anti-competitive conduct. To address these challenges, Google must divest Chrome, which has forfeited Google's dominance, so that rivals may pursue distribution partnerships that this reality of control today prevents. As to Android, a critical platform on which search competitors rely, and for which Google has myriad obvious and not so obvious ways to favor its own search products. There are 2 options. One that swiftly, efficiently, and decisively strikes at the locus of some of the anti-competitive conduct at issues here, and a second option that invites court and plaintiff oversight into long-term behavioral remedies that may be protracted and less certain due to Google's conduct. The most straightforward solution, the first option, would be to divest Android, which would prevent Google from using Android to exclude any of their search rival search providers. But plaintiffs recognize that divestiture may draw significant objections from Google or even other market participants. So again, these are pretty massive things to be stating, and again, these are just recommendations, how the government wants to move forward, right? But the government's pretty dead set on getting Google basically broken up beyond where it already is. So what they said was the proposed final judgment. Guided by governing case law and with these market realities and dynamics in mind, plaintiffs respectfully submit the initial proposed final judgment, which provides the court with a comprehensive and unitary remedy to address the harms in the general search services and search text advertising markets, ensuring that Google cannot further cement its monopolies by engaging in anti-competitive conduct. So what they have said was plaintiffs propose a variety of interconnected and self-reinforcing remedies to 1. Stop and prevent exclusionary agreements with third parties, 2. Prevent Google from self-preferencing through its ownership and control of search-related products, and 3. Prevent Google from stifling or eliminating emerging competitive threats through acquisitions, minority investments, and partnerships. 4. Disclose data critical to restoring competition. 5. Increase transparency and control for advertisers. 6. End Google's unlawful distribution. And 7. Allow for the enforcement of the PFJ while preventing circumvention. So when it came to selling Google Chrome, really the most important part, they actually provide that Google, like the PFJ further provides that Google is prohibited from owning not only a browser following the divestiture of Chrome, it may not re-enter the browser market for 5 years, but also from owning or acquiring any investment or interest in any search or search text ad rival, search distributor, or rival query-based AI product or ads technology. So they really want Google out of the game. They really want to remove them from the entire world of actual like Google searches, or not Google searches, but distributing these browsers and having their dominance. Now, again, I think that some people can probably say, Muda, what about like the idea that, hey, Google made a really awesome web browser, and clearly shouldn't they deserve to profit off of something like this if they made a genuine good product that everyone wants to be using? No, the idea about Google is, at the end of the day, Google Chrome is built off of something known as Chromium. So this is where we get to this double-edged sword. Now, if you want Google to basically cut off Chrome, somebody is gonna have to buy it. The thing about it is, people have valued Chrome to be around like worth 15 to 20 billion dollars. But in reality, something is only worth whatever anybody is willing to pay. Now, the thing about Google Chrome is people already develop their own browsers through Chrome technology. Now, this is Chromium, which is basically the parent, software of Google Chrome. So when Google develops updates for Chromes, they then back upstream their actual code to something known as Chromium. So when you see Microsoft Edge or Brave or Opera GX and all these other different browsers that you've come to know and use, they basically download the source code provided by Chromium, which ultimately is led by the development over at Google. So people grab this software, they add their own proprietary bits and blobs, and they distribute it out to the average person, right? So effectively, most of the browsers in the world that is being used right now, so whether you have Google Chrome, Microsoft Edge, Opera GX, Brave browser like I use, we're all basically using a variant of Chromium at some point. So basically, by removing Google from actually being behind this project, it can actually be kind of disastrous. Because if you're removing the chief developer on this, then it can actually stagnate the development, right? If you're removing Google's incentive to be on this project, it can be tough to actually see development go on forward. It's not as if Chrome is going to disappear, however. Because the source code is open and it's available, someone will pick up the slack and still continue to develop Google Chrome. Whether you have Brave developing their own version, you have Opera GX working on their own version, or you've got Microsoft Edge pumping away at their own version, right? So again, everyone will have some level of Chromium still out there. But for Google, if the government really boots them out, they really won't have anything to say. And at the end of the day, there is one silver lining here. Because of Google's dominance on the web through its web browser, they've basically been deciding the standards for the internet. There's no doubt that if you want to access YouTube or browse Google services, it is best done on Google Chrome. So having Google removed from basically softly deciding how the internet standards are set may ultimately be a good thing in the long run, right? Like obviously, if you let the entire world decide what the standard of the internet will be, it means we all control the internet and not just Google. Google is not the deciding factor in how the internet will be designed going in forward. So that is the one big silver lining to really consider here. Now, the thing about this Google stuff, this Google Chrome stuff, is that it reminds me a lot of like the original browser wars. Now, if you're old, if you're somebody that has been following the early days of Microsoft, you may remember this video clip of Bill Gates in the middle of a Microsoft antitrust deposition. And this was all related to the first ever browser wars. So much like the nerdiest war you've ever heard of, the browser wars were actually brought forward in a discussion of Microsoft basically dominating the market at the time. And this is the late 90s to around the early to mid 2000s. So if you're looking at this graph right over here, in 1996, one of the largest browsers available was one known as Netscape Classic. Now, I've probably shown you Netscape at some point on my channel, but if you're, again, if you're younger than me, if you're like somebody who's of the TikTok generation, you probably might not even have heard of what Internet Explorer is. So if you've been around since the beginning of the internet, Netscape is something that people use. Netscape used to be a commercial software. People had to pay to buy a web browser that they could then access the web in an easy fashion. Now, obviously, Microsoft then came in by releasing Internet Explorer, so this blue section, as part of Microsoft Windows. Basically, a part of the actual software was included for free. So because Microsoft released their stuff for free, bundled with, again, Microsoft Windows, which is one of the most used operating systems ever, they basically took over the entire market. And for a while, until Google Chrome came in, the only dog in this race was Internet Explorer. Yeah, there were other people like Firefox and there was like other browsers, but generally the internet was... Alright, so I'm going to walk you gamers through the browser wars pretty quickly, okay? Now, ladies and gentlemen, somewhere around the time of the late 90s, there used to be other web browsers that weren't Microsoft Internet Explorer.